A ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 0.6 feet per second, how fast is the angle between the ladder and ground changing when the bottom of the ladder is 6 feet from the wall? This looks similar to another problem, but this one is relying on the angle instead of just how fast the top or bottom of the ladder is sliding. So again, we're going to want a diagram. Let me make a quick one. So here we are. We know the ladder is 10 feet long, so we can mark that as 10. That is a constant. The ladder's not going to get longer or shorter. We can label the height y, and then the distance from the wall x. And we want to know about the angle between the ladder and the ground, so we're going to call that theta. Now we want to know the rate of change of theta, and the rate of change that we're given, 0.6 feet per second, is the bottom of the ladder sliding away from the wall. So we know the rate of change of x, and we want the rate of change of theta. We don't know anything about the rate of change of y, so we need a relationship between x and theta, and maybe 10, but not y. And the relationship I see here is cosine. Basically, cosine of theta is going to be x over 10. So that is the relationship that we can leverage here. We want to differentiate both sides of this with respect to time. The derivative of cosine is negative sine. So we've got negative sine of theta times d theta over dt. And then the derivative of x over 10 is 1/10, but then times dx over dt, because x is a function of time. So now we've got all of those things in. We are going to need to know what sine of theta is. Sine is opposite over hypotenuse, so we're going to need to know the value of y. I'm going to draw a very rough diagram of what we've got here. We've got 10 theta. At this particular moment, we're told that the bottom of the ladder is 6 feet from the wall, so we know that this is going to be 6. We can use the Pythagorean theorem to find the height. I'm going to let you do that on your own and just tell you that it's going to end up being 8. 6 squared plus y squared equals 10 squared, and then you solve for y, you get 8. And so if we want sine of theta, that is going to be 8 over 10, which is going to reduce to 4/5. So we've got negative 4/5 times d theta over dt equals 1/10 times dx over dt. Now, we know that the bottom of the ladder is sliding at a rate of 0.6 feet per second, and so dx over dt is going to be 0.6. Let's see. So we want to get d theta over dt alone, so we can multiply by negative 5/4, the reciprocal of this, to get rid of that on the left. So we're going to have d theta over dt equals 1/10 times 0.6 is the same as 6/10 or 3/5. I'm just going to make them all fractions. There's no sense in dealing with fractions and decimals. And then times, remember we wanted the reciprocal of negative 4/5, so that's negative 5/4. And then we've just got some math with fractions. We can cancel out the 5s. That's going to make this a negative 1 up here. And then that's going to give us, what, negative 3 over 40? I think that's what we've got, negative 3 over 40, which we can also write as negative 0.075. And this is going to be in radians per second. So that angle is decreasing at a rate of 0.075 radians per second.